This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The fourth type of this question are questions where we are given the length of the radius, a line through the centre, and 1 point on the circle. So, in our example here, we are told that a circle has a radius length of square root 20 and contains the point -1, 3. Its centre lies on the line x plus y equals 0, and we're asked to find the equation of the circle that satisfy these conditions. So in this case, we notice that we're asked for two circles. So we'll see where this comes in later down the example. So just as in all of our other questions of this type, we'll write down our general equation, and we're going to look to find three equations that we can solve to get our values for g, f, and c as always. So first, we're told that the point -1, 3 lies on our circle. So if we fill in those values, so our x is -1 and our y is 3 into our equation, then what we're going to end up finding is an expression here that we get -2g plus 6f plus c is equal to -10, and we'll call that equation 1. Next, we're told that our center, which we know for equations of this type is -g minus f, lies on the line x plus y equals 0. So our second equation is got -g minus f equals 0, and we'll call that equation 2. We also know the radius formula for circles of this type is square root g squared plus f squared minus 6, and we're told that is equal to square root of 20 is our radius length. Squaring both sides of this equation means the square roots will disappear, and we're left with an equation g squared plus f squared minus c equals 20, and we'll call that our equation 3. So moving down along, from equation 2, we can see that if we just bring our f to the other side of this equals, so add f to both sides, we get -g is equal to f, or just rewriting that, f is equal to -g. So if we fill that into our first equation, we'll get an expression here that involves just g and c, because our 6f changes to a 6 times -g, because we were told here that f is equal to -g, so that goes in here. And we get that -8g plus c is equal to -10. Now what I'm going to do next then is from that I will get the value of c to be 8g minus 10. Now the reason I'm doing this is since I now have a value for f and a value for c that are both only in terms of g, so we have f is equal to -g, so f is equal to something involving g. C is equal to 8g minus 10, so c is equal to something involving g. If I take those two values there in my red boxes and substitute them into equation 3, I'll end up with an equation that only involves g. So where I have f in equation 3, so just to remind you from above, I'll write it here, we had g squared plus f squared minus c equals 20. So that's this equation up here. I now have an expression for f, so I can take that and fill it in here where I have f. So this f here. I also now have an expression for c, so I can fill that in here. So when I do that, I get g squared stays on its own, but instead of f, I write minus g squared minus c. So c is 8g minus 10, so I'll leave that in the bracket, equals 20. So now I'm going to simplify this equation. So a minus g squared is the same as g squared. Minus 1 times 8g is minus 8g. Minus 1 times minus 10 is plus 10. That equals 20. Simplifying this by adding our g squareds, so we have 2g squared. Bringing our 20 to the other side, we'll have a minus 10. So we have 2g squared minus 8g minus 10 equals 0. If we divide everything by 2, we get g squared minus 4g minus 5 equals 0. So now we see in our question we were asked to find the equations of the two circles that satisfy these conditions, and you can see here now what we have actually found is a quadratic equation for g. So you'll know that when you have a quadratic equation, that means you have two roots. So we'll have two answers for g. And if we have two answers for g, so in this case g ends up being minus 1 or g is 5. If we have two answers for g, that means we're going to end up having two answers for f and two answers for c, which means we'll end up with two different equations that satisfy the conditions given in the question. So like I said at the end of the last slide, now our task is to find g and c, but we have two different values for g. So we'll get two different values for f and two different values for c. So if we look for the case where g is equal to minus 1 first, we had the equation that f is equal to minus g, so f is minus time of minus 1, so f is equal to 1. C, we had an equation for c, which was c is equal to 8g minus 10, so filling in our minus 1 into that equation, we end up finding that c is equal to minus 18 in that case. If g is equal to 5, we had f is minus g, so f ends up being minus 5. We had c is 8g minus 10, and in that case, when we fill in g is equal to 5, we get c is 30. So now we can write out what our final answers are. Our answer for when g is minus 1, f is 1, and c is minus 18. We fill in those values and we get an answer of x squared plus y squared minus 2x plus 2y minus 18 equals 0. Our answer when g is 5, f is minus 5, and c is 30 will be x squared plus y squared plus 10x minus 10y plus 30 equals 0. And those two equations there, those are our final answer.